بسم الله الرحمن الرحيم.
I think most people would agree that very few things in life are absolute. When you're at the car dealership, for example, and the salesman says, "This is my absolute lowest price," it's safe to say there is still a little bit of wiggle room there. Or if you ask your friend what their favourite food is and they say, it depends on my mood, the time of day, etc., etc. It depends. How often have you heard that in response to a burning question? Life, it turns out, is pretty relative, and you'll be happy to know that Einstein would agree. In his theory of relativity, Einstein asserts that both time and space are relative concepts, debunking Newton's theory that time and space are absolute. In fact, the only absolute constant in Einstein's special relativity is the speed of light. Its value will always measure the same for any observer in uniform motion. It will always be about 300,000 kilometers per second in a vacuum and never faster. According to NASA, before 1905, when Albert Einstein published his theory of special relativity, most people believed that space and time were as Sir Isaac Newton described them back in the 17th century. Namely, that space was the fixed, unchanging stage upon which the great cosmic drama unfolded, and that time was the mysterious universal clock in the sky. Sounds like an elaborate Broadway production, albeit a fantastical one. However, numerous real-world experiments over the last 100 years indicate that it was Einstein, not Newton, that was right. And thank God for that, because if we didn't have Einstein's theory of relativity and Newton had been right, many technologies that are part and parcel of our modern world would not have worked as they do. For example, the Global Positioning System, or GPS navigation as we call it, the nuclear power plants, electromagnets and generators that we all rely on, they all work using relativity. So let's take a closer look at Einstein's theory of relativity. Jesse Emspak, a physics contributor for Life Science, describes it as deceptively simple. First, there is no absolute frame of reference every time you measure an object's velocity or its momentum or how it experiences time. It is always in relation to something else. Second, the speed of light is the same no matter who measures it or how fast the person measuring it is going. And third, nothing, and I mean nothing, can go faster than light. The implications of Einstein's famous theory are profound. If the speed of light is always the same, it means that an astronaut going very fast relative to the Earth will measure the seconds ticking by slower than an earthbound observer will. Time essentially slows down for the astronaut, a phenomenon called time dilation. But that's not all. Another peculiar aspect of Einstein's theory of relativity is length contraction. So in the same example as before, if you were to stand here on Earth and wave at the astronaut's spaceship as it speeds by, it would look as though it was squished in the direction of the motion, meaning if the spaceship is moving horizontally, then it is the horizontal dimension which is contracted with no contraction of its height. If the spaceship were moving slowly, the level of contraction or squishiness that you would observe would not be noticeably significant. But if it were moving at relativistic speeds, speeds that are a significant fraction of the speed of light, as spaceships tend to do, the length contraction would be significant and actually observable to you. This phenomenon is not due to errors in measurement or faulty observations. The object is actually contracted in length, as seen from the stationary reference frame, U. The amount of contraction of the object is dependent upon the object's speed relative to the observer. So in short, the faster the spaceship is moving, the more contracted it will appear to you. Yeah, I know, 2 words, mind-blowing. Professor James Colata, in his book Elementary Cosmology, From Aristotle's Universe to the Big Bang and Beyond, published in 2015, explains that neither time nor space are absolute quantities by asking us to imagine a meter stick lying on the floor of a room with one end against a wall. Bright lights are shining from the ceiling and the other wall. Now let us rotate the meter stick while looking at its shadows on the wall and the floor. At first, the shadow on the floor is almost equal to 1 meter in length, and the length of the shadow on the wall is very small. As we rotate the stick toward the vertical, the shadow on the floor becomes shorter and that on the wall becomes longer. When the stick is vertical, the shadow on the wall is 1 meter in length. It turns out that something similar happens in the case of special relativity. As the speed of an object increases, its length, in the direction of motion, becomes shorter, while the intervals become longer. It's interesting that the professor chooses this particular example to demonstrate the conclusions and consequences of the theory of special relativity. It's especially interesting because the Quran used the same analogy in its verses. In chapter 25, verses 45 and 46, it says, "Have you not considered your Lord, how he extended the shadow, and if he willed, he could have made it stationary? Then we, God, made the sun its guide. Then we, God, reduced it little by little." The scientific explanation for this verse is as follows. "Have you not considered your Lord, how he extended the shadow, and if he wished, he could have made it stationary, as in following Newton's theory model of absolute rest frame? Then we, God, made the sun its guide, since the speed of light of the sun is the only absolute constant. Then we, God, reduced it, which refers to length contraction little by little, which refers to time dilation." In this one verse, the Quran addresses the various aspects of what we now call the theory of special relativity, length contraction, time dilation, and the speed of light as being the only constant. Additionally, the Quran warns us that God could transform our lives from Einstein's physics to Newtonian physics if he wished. And this is possible because God did not just discover the theories of physics, he actually created them. So the next time you respond to someone's question with "it depends" and they get mad at you for not giving them a definite answer, remind them of Einstein's most famous theory of special relativity, and they might just forgive you for it.